In this video, we're going to be looking at an overview of Stellarium. Stellarium is a free open source planetarium software that can be obtained by downloading from www.stellarium.org. Once you load it and install it, you'll be able to see the sky the way it looks from anywhere on Earth. In fact, anywhere in the solar system. You can select here. We notice that we have selected the location for Laredo, Texas, with a latitude of plus 27 degrees 30 minutes of arc and 23 seconds of arc, and a longitude of minus 99 degrees 30 minutes of arc and 27 seconds of arc. So we are seeing the sky from Laredo, Texas here. You notice that we've got Polaris, and this is we're looking straight to the north. This is the northern horizon. If we go a certain number of degrees, and that happens to be the latitude of Laredo, Texas, that happens to be 27.5 degrees or so above the northern horizon. That's where we find Polaris, or very close to it. That's where the North Celestial Pole would be found. You also see that some other stars that are labeled here, for example, Capella. We can also add with Stellarium, we can add the outlines for the constellations and also the names of the constellations. You see here Ursa Minor, the Little Dipper. You see Polaris on the tail there, Draco, Dragon, Hercules, Auriga, Capella. And we can also add an equatorial grid. The equatorial grid has the coordinates, these coordinates of the celestial objects on the celestial sphere. We'll come back to that in a minute. And we can also add an azimuthal grid, which has the coordinates based on the azimuth, or as you go all the way around the horizon, all the way around 360 degrees. 0 degrees would be north, 90 degrees would be east, 180 degrees would be south, 270 degrees would be west, and back to north at 0 degrees. And as you go up on this dome, this imaginary dome, the highest point in the sky at your zenith would have an altitude of 90 degrees. Now let's look at the coordinates on Earth. We know that we use latitude and longitude. Latitude is relative to the equator. The equator is at 0 degrees. It divides the northern hemisphere from the southern hemisphere. And so if we look at north latitude, that would be the number of degrees above the equator, and south latitude would be number of degrees below the equator. And sometimes we use plus to signify north of the equator, and minus or negative degrees to signify locations below the equator. So these would be the parallels of latitude, or lines of latitude. And in terms of longitude, we have these lines of longitude, or these meridians. And the prime meridian, that's the reference meridian. The prime meridian, that's where 0 degrees longitude is. To the east of that we have positive longitude, and to the west of that we have negative longitude. Or sometimes you'll hear longitudes referred to as 90 degrees east longitude, 200 degrees east longitude, all the way back to 0. Now when we talk about coordinates on the celestial sphere, we use something similar to latitude and longitude, but these are right ascension and declination. we start off with the projection of the Earth's equator onto the celestial sphere, and that corresponds to the celestial equator, this circle on this imaginary sphere, which is called the celestial sphere, and that denotes 0 degrees of declination. So declination is measured relative to the celestial equator. Positive declination is above the celestial equator, negative declination is below the celestial equator. Notice that we also have here this circle, which represents the ecliptic or the apparent path of the sun across the sky. For what corresponds to essentially longitude or lines of longitude on Earth are the right ascension lines, and these are relative to the point where the ecliptic intersects the celestial equator. In other words, during the vernal equinox, when the sun is on the celestial equator, that's taken to be the reference point for right ascension. So that corresponds to 0 degrees or 0 hours, because right ascension is measured in units of time. Since we have 24 hours in a day, that represents, we divide up the entire circle, which is 360 degrees, into 24 hours. So we see that 1 hour corresponds to 15 degrees. So we would have 1 hour of right ascension, 2 hours, and right ascension is measured to the east. So here we see, again, we're looking towards the north, the northern horizon, and we see here the North Celestial Pole, and very close to the North Celestial Pole is the star Polaris. It's not quite on the North Celestial Pole, it's slightly offset, but it's very close to it. And the North Celestial Pole is the same altitude in degrees as the latitude of the location where you're on the Earth. So for Laredo, Texas, we have 27.5 degrees, so the North Celestial Pole would have an altitude of 27.5 degrees above the northern horizon. Notice also here that I've set the date to January the 1st of the year 2000. Just picking an arbitrary year here. Okay? So we see here that this is the equatorial grid with coordinates given in terms of right ascension and declination. So the declination of the North Celestial Pole would be plus 90 degrees, or 90 degrees above the celestial equator. And we see here that these lines, this one corresponds to plus 30 degrees, plus 40 degrees, plus 50, plus 60, 70, 80, and 90. And we also see the right ascension lines, and the right ascension lines, they're a little bit harder to see, but here we have 21 hours, 22 hours, 23 hours, and we don't say 24 hours, we just go back to 0 hours. Remember, the 0 hour reference is at the vernal equinox. If we look at the eastern horizon, we see here the superimpose the right ascension and declination lines, the grid, and we see that passing through the eastern horizon due east, that's where the celestial equator crosses the horizon. So this here at 0 degrees, this corresponds to the celestial equator. Above that at plus 10, and below that at minus 10. So here, if we were looking towards the southern horizon, we cannot see the south celestial pole. It would be below the horizon by the same amount that the north celestial pole is above the horizon. From Laredo, Texas, that would be 27.5 degrees below the horizon. You happen to see the sun here following one of these arcs. of declination. And when we look straight towards the western horizon here, we see that the sun is getting ready to set here and following one of these lines of declination. Looking towards the western horizon, we see again that the celestial equator intersects due west, and we see also that the sun is setting south of west, because again this is January. It's in winter, during winter, so it's south of the celestial equator. Now here we're going to look at a time lapse. You see, as the earth rotates, you see that the time here is passing by, 16, 17. The sun is setting in the western horizon. You see these objects setting also, Uranus, Mars. As we look toward the northern horizon, we can identify Polaris, and we see that the stars that are above the horizon, all of these stars are the circumpolar stars. They never set. Looking toward the east, we see that all objects rise in the east. Here we see the moon rising, we see Venus rising, following a path that is parallel to these lines or circles of declination. The sunrise. The sun is rising south of east because it is winter after all. And then if we look straight towards the southern horizon, we see the sun following the curved path across the sky. And looking toward the west, we see the moon setting. And we see the sun about to set. And now the celestial objects, stars, planets appear. Uranus is setting, Mars is setting, and so on.